Hello everybody, this is Yakov Fain, and today we'll talk about TypeScript. And specifically, this is a book that was published recently, like a month ago, or maybe a bit more. TypeScript Quickly, you should be able to see it now. This book consists of two parts, basically. The first part is the language itself, TypeScript syntax, basic context, many different small examples. And this part is like 170 pages. And the second part, which is another 300 pages, a bunch of different apps, a bunch of different applications which illustrate how to use TypeScript in different settings. With different frameworks, you will see how to use TypeScript with the Angular, with React, with Vue, and also we created an app which explains and illustrates the blockchain technology. And this app is written and rewritten using different technology, and the common denominator over there is that all these apps are using TypeScript. So today I am planning to show you like bits and pieces, fragments from the first part of the book, which illustrate the syntax of the language. Also, I would like you to note that I started recording videos that would help you in reading the book. At least the first part. I'm planning to record a bit more videos that illustrate the content from the first part of the book. The screen that you see now, the YouTube channel, if you will go on YouTube and if you will Google TypeScript Quickly, Yakov Fain, you will find this playlist. And as you can see now, there's a bunch of lessons over there already. Which one of them, how many, sorry, 19 lessons, I guess. 19 lessons are there. And I'll keep creating lessons so you will have more video materials. Now, so what do we do today? Today I'll start with telling you why I like TypeScript, why you should consider programming in TypeScript, and you can be either a JavaScript programmer or non-JavaScript programmer. So there are two audiences that may consider TypeScript and may decide if it's a good fit or no for them. So I'll tell you my experience, and I'll tell you what do I see in the field when I teach classes, when I see people from different enterprises, and I see a really positive reaction to TypeScript. And then I'll show you a couple of samples illustrating this language. We'll see how it works. So hopefully you will appreciate this language, and we'll consider this as a next language for you. So I will just show you one more resource. I also have a blog, and the address of the blog is yakovfain.com. yakovfain.com. If you will go there, in this particular case, you see a URL of a specific blog, which is titled White Programming TypeScript. But I have a bunch of different blogs specific to TypeScript, specific to Angular. The older one are about Java, some posts on JavaScript, RxJS. You'll find there tons of technical blogs. So if you are interested, and by the way, the link to the videos on TypeScript for the book is there. Meanwhile, what I'm going to do, I'm going to be opening up different chapters from the book, several of them, and I will tell you the story basically, but if you have already the book, or maybe you will get it, you will be able to read all that as well. So the intro is basically why programming TypeScript. Why would you consider programming in TypeScript? And what is TypeScript? TypeScript is a language which is compiled into JavaScript. So basically the process goes like this. You write something in TypeScript, you start the compiler, and compile, and you get the JavaScript piece, the equivalent JavaScript. This JavaScript can be used anywhere where JavaScript can be used. So it can be used in HTML pages, it could be used on the server side, it could be run separately as a program, and you can see the output on the console. So the question is that you may ask, or you may have, why bother? Why should I even bother writing something in language A and then compile it to language B, in this case JavaScript, if I can just write code in JavaScript without all these troubles? So what is the benefit? Why would I do something like this? And I'll try to cover this. Sorry, there is like some sirens, some on the street. I'm in New York City, so maybe it's an ambulance or something. So why program in TypeScript? First of all, in my opinion, when I say in my opinion, it's an opinion of a person who spent many years working with different programming languages, and most of my programming experience is in Java server-side mainly. And I know the language, I know how it works, I know how compiled languages work, and being a Java developer for the most of my life in programming, I can tell you that Java developers look kind of down on people who work in JavaScript. They think to themselves, Java is a real language, but JavaScript is a toy. It's unpredictable, it may or may not work, people make fun of JavaScript. It doesn't tell you if you make an error, if you type something and you make a mistake. What kind of mistake? JavaScript is a dynamic language. So if for example, you declared a variable of type string, but you assigned a string to it, and somewhere else you assigned a number to this same variable, so the type of this variable automatically is changed to number. In JavaScript, you don't even have a chance to declare a type of a variable. You don't need to declare a type. So all these little things may cause problems when the program is deployed in production. You write a function that has 5 arguments. What are they? What are these arguments? Are they all numbers, or maybe some of them are strings? How are you supposed to know? Oh, you are a smart programmer and you can read the body of the function and you will figure it out. What if somebody else will be reading your code? What if you made a mistake and assigned the value of the wrong type? What if you have a function that's supposed to get an object of type user, and somebody who sends you the data, for example, the data comes from the server side as a JSON. Somebody on the server side added a couple of fields and they forgot to tell you about it. You are a front-end developer, right? So the structure of the object is different. Your code may crash during the runtime. Then you'll figure it out and you will fix it. But wouldn't it be nice if you could fix the problem sooner, before deploying the code in production? Let me show you a quick little sample. And what I'm using now, I'm using so-called Playground, TypeScript Playground. So there is a site called TypeScriptLang.org. And if you go there, you will see this menu, Playground, right there. Playground. In there, you will see the script, the screen split in 2 parts. On the left, you can type something. You can type the code in TypeScript. And on the right, you will see the equivalent in JavaScript, the compiled version. Let me get rid of this piece. And let me start typing something. For example, let x equal 3, for example, something like this. I wrote this line in TypeScript. And on the right-hand side, you see its equivalent in JavaScript. And you can tell me, these lines are, these both versions are the same, right? It's right because I didn't use types on the left. Let me do this. Let me declare that the variable x has a type number. Take a look at this, by the way. A number. See, I'm making mistakes. I'm getting help, autocomplete, and IntelliSense, right? So I will not make a mistake. So look at this. On the left-hand side, I declared a variable x of type number, and I assigned 3 to it. On the right-hand side, you see a transpiled version. By the way, the word transpile, it's like compiled, but a compiler would compile the source code in any language into a machine code or maybe into a byte code. But when you say the word transpile, we mean that the code will be compiled from one source language, from the source in one language, to the source in the other language. Somebody says, I will make the screen smaller, maybe that's why you don't see the JavaScript portion. Yeah, I see you. You should be able to see it now. For some reason you don't see the entire screen of mine. How about now? I made it a little smaller. Yeah, it's better, right? Please confirm that it's better. Okay, so as you can see on the right-hand side, you see the JavaScript version of the code, but without the type, without the number. All right, so to transpile means to convert the code from the source in language A to the source in language B. So if this would be a real project, we would be deploying this piece of code. So browsers or any other JavaScript language, they still need JavaScript. They don't run TypeScript. So there is a process, there is a step to compile. Now let me show you another example. Let me do this. Take a look at this function on the left. Ignore what's happening on the right. And as a matter of fact, it is JavaScript on the left now. What I will do now, you see a couple of lines of a couple of variables, actually arguments of the function, point A and point B. They are underlined with this squiggly red line. This is basically TypeScript compiler complaint. Remember, on the left we see the TypeScript compiler. It complains saying that since you didn't declare the type of this parameter, it's assumed that the type is any. Any is a bad practice, and you shouldn't be doing this. They say that. So what I will do, there is a config. I can configure the TypeScript compiler. See, this is a checkpoint. It says no implicit any. Don't do this. Don't assume that the variable has a type any. Let me uncheck this. Let it see. Now it'll allow me to have implicit any type. Anyway, so the good part about TypeScript that it has optional typings. Types are optional. It's not like in Java. If you won't declare the type of a variable, it won't work. It will, and that's the beauty of it. So if you have a JavaScript project with a code base already written, and you want to go in the TypeScript direction, and you want to move to TypeScript, you don't have to declare a type for each and every variable. No, you don't need to do this. See, as you can see, it doesn't complain because TypeScript is a superset of JavaScript. Valid JavaScript code is considered to be a valid TypeScript code. And you can see it over there. So what's the problem in this example? Anybody can look at it, take a look. It's basically Pythagorean theorem, if you remember. A power of 2 plus b power of 2 is equal to c power of 2. It could be used in particular to calculate in geometry. So let's not go there, but take a look at this code on the left, guys. Do you see any issues in there? I'll give you a moment or two. Meanwhile, I'll take a look at the chat. Somebody is saying you need the type of the parameters. It's optional. Yes, I need it, and I will show you how I will add it now, but it's optional in TypeScript. it complains, but it can run. Yes, basically in TypeScript there is an option that is, I don't know if they have it over here, but if you would be using IDE, one of the IDEs, I'm using this playground thing because for me it's more, it's easier to show you something. But if you'd be using regular IDE, there or you also can specify the parameters of the compiler, and one of them is no emit on error. If you would say that, if you want to go all the way down and say I'm using TypeScript, I will declare the type for each and every variable. Then it'll produce the code anyway. If you don't want this to happen, you can say no, don't emit the code if there are any errors. In that case, the code wouldn't be generated. But in this particular case, from the JavaScript perspective, this code is valid. There's no errors, right? Anybody see a problem? Yes. There's a guy called Gray Programmer, and he says the Z member of an instance, line number 7. Very good. Congratulations that you are experienced person and you notice that thing, that little thing. Look at this. I wrote a function called distance. It's assumed to take, it assumes that I'm going to provide two objects, right? There's a point A and there's point B, and I want to calculate the distance between the two, right? And I'm using, see this, I'm taking a square root from A minus X coordinate of A minus X coordinate of B in power of 2 plus X Y coordinate of point A minus B power of 2, right? So I'm supposed to give the object that represents point A and an object that represents point B. In JavaScript, in this case, I'm using object literal notation, right? So what did I do? I made a mistake. I assumed that this point has the property Z, which it doesn't. So the whole thing wouldn't work in JavaScript. JavaScript wouldn't catch this error, and I could deploy this super important code, and I could deploy it in production, and boom, it blows up. Right? Because I'm using JavaScript, there is no type checking. They assume that I'm good enough, like in this case, Gray Programmer. Right? Or this little thing, you're right in saying that it may take a long time to find this little thing. And it's just a 7-line piece of code. Think of a large project. All of a sudden it blows here, it blows there. So what would I do with this little code on the left to introduce type, to show you the advantage that TypeScript brings to the table right away? So what I would say, you know what? I need to define a type that represents a point. I need to calculate the distance between point A and point B, or maybe something else. So how can I do this? There are different ways of doing this. Let me do this. I will declare a class. I will call it point, right? And in there, I'll declare two properties. One of them is X of type number. See, I'm writing TypeScript now, and the other options. See, compiler. In TypeScript, there is a thing called TypeScript language service. It's like a big brother. It is sitting there and watching what I'm doing. In this particular case, it says property X has no initializer and it's not definitely assigned in the constructor. All right, so it's another option. It wanted me to declare a property and assign it to initialize it with 0 or something. But again, it's an option of the compiler. I'll shut it down. Where is that? Strict property initialization. I will uncheck this option so it wouldn't complain about that. All that is configured, of course, on the compiler. And the variable y of type number, right? So I declared a new type. I declared a new type, class point, which has two members, and both of them are numbers in this case. So far, so good. But I didn't use it anywhere in the function distance, and I will now. Look at this. I will start declaring that point A is of type point. But meanwhile, keep an eye on this line over here. as I type, it'll notice that Z is wrong. Z is not existing property of the point type. Column of type point. See, it helps me. It tells me what can I put in there. Look at this. I didn't even finish typing. Look at the line number 9. Oh, 12, sorry. Look at this. It says what? Argument of type, curly braces, object literal, Z number, Y number is not assignable to parameter of type point. Of course, it's not a point because it has no Z. Of course, I will do the second argument of the type point as well. See, I am still typing. I didn't deploy anything. And it already tells me that I'm wrong. Isn't it beautiful? It is. Trust me, it is. You can say, I'm a JavaScript developer. I don't want to bother declaring type. I will never make this mistake. You will. You will. We talk about productivity, which increases. You don't need to deploy JavaScript to see this error. Now, since we are looking at this little example, I want to show you something else. So how do you declare types? First of all, there are basic types like number, string, boolean. They already come with the language. But you can define your own type. Like in this case, I was using the keyword class. By the way, JavaScript has classes as well since 5 years ago, since ES6 spec. And look at this. On the right-hand side, the JavaScript code was generated based on on the left-hand side, TypeScript code. In this case, in JavaScript, you can compile your TypeScript down to different specs of JavaScript. ES5, ECMAScript 5, even the oldest, super oldest one, ECMAScript 3, ES 2015, which is also known as ECMAScript 6, ES6. All these, every year they release a new version, right? Let me do this. No, they didn't do it yet, I guess. Basically, what I wanted to show you, right now, there is a proposal to introduce fields in the class in JavaScript, right? So these would be fields. So some browsers already support it, in particular Chrome supports it, but if it will become the final version, final stage of the ECMAScript, fields in the class, and then we would see fields in there. For now, it doesn't exist, so it just said that it should be class point with no properties. In here, it ignored the type because, once again, because JavaScript doesn't have types. Now, what else I could have used in here? I could have used the keyword interface instead of type. Look at this. All of a sudden, on the right-hand side, I don't see anything generated for this point. No footprint at all. So, if you want to declare a type and you are not planning to instantiate objects of this type, I declare a type. In this case, I just only want to use it as a type. I'm not planning to create an instance of a point, right? In this case, I only use the, what do you call it? The object literal. If you just need a type, so to do the type checking as you write the code in development mode, just use interface. Or there is another keyword called type. The good part is that since JavaScript doesn't have this construct type, it will not generate any equivalent code. If this would be a large data type, for example, user, 25 fields, or maybe order, you're placing order, or maybe shipment, 25 fields, 20 fields, 15 fields, it's a good idea to use interfaces. Why? Because it doesn't generate code in the production version. So your code base becomes smaller. So these little things already show you that you can get benefits right away. Even even if you will try to run your existing JavaScript code through the TypeScript compiler, you may be surprised. And it'll try to compile your code. It's supposed to be able to generate JavaScript from valid JavaScript. If you had some little bugs that you never even noticed, maybe they showed up in production but nobody noticed, TypeScript compiler will check it out for you and will say this is wrong, and that is wrong. Sometimes you will read in blogs, in books, in articles, that TypeScript is a superset of JavaScript. Meaning what? Meaning that whatever JavaScript understands, the syntax, should be understandable by TypeScript as well. So ideally, if you will take any file with extension .js for JavaScript and just rename it to .ts, you should get a valid TypeScript program, with some exceptions. For example, in JavaScript, you can dynamically assign fields to the objects. This is not allowed in TypeScript. These cases would generate errors in TypeScript. You may have bugs. For example, you have a function in your existing JavaScript program. You have a function that expects the type string, and you put number in there. Somehow it worked. TypeScript compiler would help you out. Now, what is so special about TypeScript? It's already second year in a row Stack Overflow developers are filling out the survey, and different things. What is a popular framework, the popular language, this and that, tools. TypeScript is second year in a row is in the first three most loved languages. People want to learn it and use it. We have another maybe half an hour, so I don't have much time to explain you all the details, but I can answer the question, what is so special about TypeScript? It's not the first time when somebody is trying to create a language which would be compiled into JavaScript. There's like 100 of those, maybe less, for CoffeeScript, for example, right? What's so special about TypeScript? Why specifically TypeScript is getting popular? A couple of reasons. First reason, of course, is that TypeScript is created by the person who already created C#, Delphi, Turbo Pascal. His name is Anders Heilsberg. But that's not the main thing. Yes, he knows how to create programming languages, but what is really, really important is that they play by standards. There is a standard body, TC39, and every year they release a new spec for ECMAScript. ECMAScript is a specification for the scripting language, and the most popular one is JavaScript, of course. JavaScript. So, and there is a process in this TC39 body. Say I decided to propose a feature in the language. So what's going to happen? I will send a proposal, and people will look at it, and then if it will make maybe stage 1, and then stage 2, and then stage 3, and then final stage. If the proposed feature made it all the way to the stage 3 or phase 3, I don't remember, the chances are very high that it will make it into the next release of the language. So creators of the TypeScript, they don't come up with some fancy syntax out of the blue. They look at this TC39 process and they pick the features that made it to the phase 3 of the spec. And they implement it today in TypeScript. So that body, TC39, can keep working. Maybe it'll take them another year, and then the browsers will need another 2 years to implement this latest feature. But you can use it today, because as soon as the feature made it to the ECMAScript phase 3 spec, you got it in TypeScript. And the beauty is, when you will specify the compilation options, you specify target. --t, if this would be a command line, a compiler TSC, target. In here, you can pick it from the box, from the drop-down. You are saying, I want to use the best and newest features of the language available today. But I know that my user base, they have to work with older browsers, and they support JavaScript of older spec. So what you say is, you can pick any of these. For example, you can say, you know what, I want to actually, let me change it real quick so I can illustrate something. From interface, I will go back to class. The keyword class was introduced in JavaScript in ECMAScript 6 or ES 2015, right? So I go back, and by default, this option target is ES 2019. Of course, JavaScript spec 2019 supported classes. That's why it generated this little piece on the right. But what if I am told by my team lead that, you know what, we have a group of users which use older versions of browsers, and those browsers don't support ECMAScript 6 yet, or ECMAScript 2015. So what I'm going to do, I'm not going to change a single line over here. What I will do, I change the target, the compilation target. I'm going to say, you know what? Compile it down to the older version. Look at this. I will make a change, and I will say, compile it down to ECMAScript 5. I'm click on this thing now. ECMAScript 5 did not support classes, and you watch what's going to happen in the right box where the code for JavaScript is. Right now, line 2 and 3, they still have class point, but as soon as I click over here, see, it's gone. The TypeScript compiler generated a replacement for classes that were not supported in ECMAScript 5. See that? So you are safe to use latest and greatest features of TypeScript language, and still compile it down and run it in older browsers. Now I don't see the questions though. So now let me tell you one thing. I don't know what kind of people, what kind of backgrounds they have who are watching this video now, live stream. But I can tell you, I'm running trainings in the USA mainly for enterprise clients. Typically, I'm running a class for either Java developers or C# developers. And they get this language in a second. They're happy with it. They understand the concept of classes. They understand the concept of interfaces. There is something called generics. They know that you need to specify types. There's so many things that they get it right away. And all these super duper Java developers, they would say, JavaScript is a toy, I don't even want to go there. It's a dirty language. I can do classes, I can do object-oriented programming, I can do interfaces, I can do everything, they say. And now I'm showing them, you can do this in TypeScript. Go ahead. Be my guest. It's the same thing. So everybody's happy. C# developers, Java developers are really happy. That's my experience. I'm telling you, not because I read an article, because I'm running live classes or online classes. All right. Let me show you one other feature real quick. We still have like maybe 15, 20 minutes. What do I want to show you? I want to show you interfaces a little bit. Interfaces, programming to interfaces. This concept is very easy to grasp for Java developers, C# developers, object-oriented people, crowd. they know what it is for, but it's something new for people who used to work with JavaScript only. And again, interfaces are not even there. So interface, I already showed you an example. Interface cannot have implementation. In the TypeScript interface, you can declare just fields to define type, like I did with an interface point, or you can declare method signatures in there. No implementation. You can just say it's going to have a method called start, and this method start supposed to get an argument of type number, for example, something like this. So, and also you can say that a class may implement an interface. And what does it even mean? Let me click on this section. This is chapter 2 of the book, and I want to show you what do we mean by enforcing the contract using interfaces. Once again, the same idea. If you're Java or C# developers, you already understand what I'm talking about. So take a look. Let's say I want to design a program or some pieces of code to represent a car. How can you do something like this? You know that the car is supposed to have functions like start engine, stop engine, maybe brake, accelerate, honk, something like this. So when you have, if you understand the concept of object-oriented programming, if you have the language structure called interface, then you can ask yourself, what is car supposed to be able to do? As I said, start engine, stop engine, brake, and so on. But when you have this concept of interface, you don't start implementing right away. You don't just write let me write a class car and implement in there all these methods. You can think smarter. You can think like this. They want me to design a car, and they want me to create a method in there, start car, stop car, brake. But there are different cars. What parameters is this method supposed to have? Let me, instead of just jumping on it and starting writing a class with implementation, let me just define my intentions with names of the methods and signatures. So check it out. I'm saying I want to define my intentions. I want to declare an interface. See, I decided to declare an interface called motor vehicle. Any car is a motor vehicle, a vehicle with a motor. And I put in there method signature, start engine, stop engine. Over here, in this particular case, for example, it has no arguments, but I specify a return value. This is how you do it in TypeScript. After the function's name and parameters, you put colon and then the type, the return type. For example, this one returns Boolean. Accelerate. Look at this method signature. It's supposed to be called accelerate. It's supposed to take one parameter, speed, and the type of this parameter should be number. In this case, I didn't specify what it returns. If I didn't specify, I forgot or I didn't want to, which is okay. It returns nothing. It returns void. I could specify the word void explicitly. In this case, honk, I explicitly say that this function returns nothing. All right, so I defined the interface. See, I didn't even start implementing it. I didn't write a code for the method start engine. Next, what I do, I say, all right, so let me now declare a class and say that the class car implements interface motor vehicle that I just defined a minute ago. Since my interface motor vehicle has like 5 method signatures in there, by saying that my class car implements interface motor vehicle, I am saying something like this. I swear that my class car will implement each and every member of the interface motor vehicle. So I have to implement all these methods in the class car, and they must be called exactly like in the interface, and they must have the same exact arguments as I specify in the interface. Right? Now, over here, it could be something like this. For example, I have a class car, implement motor vehicle. In this case, I put very simple implementation like return true, or accelerate, print something on the console. It doesn't return anything great. So, this is valid implementation of the class car. Why? Because I didn't forget to implement any of these guys, and they have the right signature. Somewhere down there, what I do, I create an instance of the car, and maybe I invoke the method start engine on it. Let me actually grab this thing and copy it into the TypeScript Playground over here, right? So now it has a mistake. Why? It has an error, sorry, because I did not copy the method, no, the definition of the interface itself, right? So where were I? It's somewhere here, right? So this declaration I did not copy. I will fix it. Over here, so I'll put it up there. So now it'll know what the motor vehicle is. In this particular case, it doesn't include by default the library that browsers use. It doesn't assume that I'm going to be using browsers. That's why it doesn't know what the console is. But the JavaScript doesn't complain. TypeScript is picky. Anyway, so see, I have a class car. So let's say I forgot or I misspelled. I have start engine just like this. See, instead of capital E, I put in line 11. I put small e. Class car is underlined. I hover the mouse over, and it tells me exactly what I did wrong. As I type, that's the whole idea. As I type, it helps me. Oh, I see. It says that class car incorrectly implements interface motor vehicle. Property start engine is missing. Of course it is missing. It is start engine with small e, but it needs capital E. Oh, so I see right away, oh, I made a mistake. But for the JavaScript perspective, there's nothing wrong. You want me to create the class with the method start engine with a small e, fine. It attached it to the prototype. No checking at all. Interface is gone on the right hand side. There's no even one trace of it because JavaScript doesn't support it, right? So see this little error. If I'd be writing this code in JavaScript, if I would be manually writing all that you see on the right, it would go in production as is. Eventually I would figure it out. I'm not that stupid, you know. But isn't it nice that it helps me right away? Fix it and so on. So let me spend a bit more time on that part. So we define an interface. We said that the class car implements this interface. And this is what we mean by enforcing the contract. What is a contract in this case? The contract is that there's a contract between the class car and an interface motor vehicle. Class car swears, promises, say, I'm telling you, I'm going to implement everything, right? And that's what we mean by the contract. Class car says that I will definitely implement each and every method defined in motor vehicle in this case. We did this part, right? Now, in the TypeScript over here, I created the instance of the class car, line number 29. I declared a variable, in this case constant, if I'm not planning to change the assigned value to it. I said, I declare a variable car and I created an instance of the class car, and the variable car with small c will get a reference to that instance. Excellent. Excellent. And you can tell me, how come in line 29 you did not specify that the type of the variable car is car? Why didn't you do something like this? See, it doesn't complain either. I could have done this, and this wouldn't be an error. Of course it wouldn't be an error, but it may not be needed, because TypeScript has something that is called type inference. TypeScript compiler can infer what type is on the right-hand side of the equal sign. So it can infer, in this case, if I'm specifying if I'm creating an instance of new car, apparently the variable car may be of type car. It'll guess that probably the type of the variable car is car with capital C. Let me see actually. Look at this. I'm hovering the mouse pointer over the variable, and it tells me, it figured it out that it is type of car. So in many cases, if this code is self-explanatory, I wouldn't bother specifying explicitly type of the variable car. But I want to show you something else. Let me show you something else. Let's say this is correct, as we agreed, but let's say instead of the type car, I would specify the type motor vehicle. Motor vehicle. Motor vehicle. It still works. Why? What does it even mean? It means that the class car implements motor vehicle, and it's safe to assume that the class car, the instance of this class, will have each and every method defined in the motor vehicle. If I will hit control space over here after the dot in line 32, control space or command space, actual control space over here, it helps me, it tells me what is available in this particular type. Accelerate, brake, honk, start engine, stop engine. If I'd be invoking it, it would help me with parameters as well. So why would I even want to do something like this? The thing is that the class car may implement more than one interface. Let's say this is a James Bond's car and it can fly as well. So I can say, I can declare interface flyable, and in there I would declare an extra method called what? Fly, and the parameter how high. And it doesn't return anything. See, I have a second interface now, and I can say that the car implements not only the motor vehicle, but it also implements flyable. TypeScript complains, right? Why? Because I incorrectly implemented interface flyable. Meaning what? Meaning I forgot to implement the method fly that was declared in the interface flyable, right? So let me fix this part first. Let me implement it somewhere. See, a class can implement more than one interface. So let's say this is my implementation. Great. So my class car implements motor vehicle and flyable. But if over here I said that the type of the variable car is motor vehicle, only the methods defined in the interface motor vehicle will be available for the variable car with small c. Look at this. Look at this. If I will do control space in line number 43 after the period, look at this. It doesn't show me that the class car has a method fly, and rightly so, because the variable, I decided that the variable car shouldn't even see it. It'll see only those methods that are defined in the interface motor vehicle. If I will make it, if I will if I will say of type car, control space, different story. See, it also has a method fly. Now it shows me all methods that exist in both interfaces. All right, so we are on top of the hour. So this is basically what I was planning to show you today. If you have any questions, let me read the chat. I'll be happy to answer your questions. Oh, somebody won free book. Oh, somebody wants this shirt. See this? Beauty. Yeah, this Manning sent me this TypeScript Quickly. I got brown and I got black. Thank you, Manning. My picture window is blocking the code, so I look better than code. So you don't need to look at the JavaScript code. You need to look at the TypeScript code. Can't see. Thank you very much. Love the shirt. Yeah. Okay, so I don't see any messages actually, so I think this can conclude our session, right? TypeScript Quickly is good enough for the newbie? The question is yes. What can I tell you? That, as I said, the part 1 of the book is 170 pages long only. If you're just starting, read this part and put the book aside. And then slowly, gradually start reading part 2 if you feel that you are good enough with the first part and you want to go further. In the part 2, we start with explaining the technology, how blockchains work. I can tell you the story. When we started working on this book, in the very beginning, some time ago, this book was written by me and my colleague Anton Moiseev. We started to discuss what kind of a sample app we should add to the book. And we decided to show how to use TypeScript in different settings with different frameworks for developing a blockchain app. When we sent this proposal to Manning's editors, and we had a meeting in the beginning, their reaction was what we expected. They said, in a polite form, "Are you crazy? You are explaining a new programming language, and you are planning to use this complex technology to illustrate this new programming language?" And we promised, we swear that we will do it in a simple way so people will get benefits of learning two things. It's like buy one, get one free. And to the credit of Manning's editor, they agreed with us, and they let us do this, and we did it. And hopefully, I believe we did a good job. So, but again, it's a part 2, not mandatory to read to learn the language, but highly recommended, of course. And you can kill 2 birds with 1 stone, actually more than 2, because we have, for example, there's a chapter introducing Angular, and then the next chapter showing how to create a blockchain using Angular and TypeScript. There is a chapter introducing React framework, and the next chapter how to create blockchain using React and TypeScript. There is a chapter introducing Vue.js framework or library, or it's a mix actually, and how to use TypeScript with Vue. Excellent book. Let me tell you, I'm not shy, but I like it. It's not the first book that I'm writing in general, and for Manning in particular. Excellent publisher, and I really like this product.